The next thing we're going to do in this section, in 9.5, it's called completing the square. The textbook focuses on solving equations by completing the square. I'm going to split that off, and we're going to complete the square to do two things. One is to turn it into vertex form to help us with graphing. And the second thing is just to directly solve to find the x-intercepts by completing the square. So first thing I want to do is remind you that a binomial squared is a trinomial. The first term is the first term squared. The last term is the last term squared. And the middle term is 2 times the product. So 2 times a times x. Same thing here. First term squared, last term squared, and 2 times the product. 2 times negative a times x is negative 2ax. And there's a plus here. So what I want to do is I'm going to write ax squared plus bx plus c. Actually, let's get rid of the a, because that's going to be one of the things. Okay. Let's look at the relationship here to this number right here. Well, what do I have to do to these numbers in order to get to this number? What do I have to do to b in order to get to c? Well, notice that this just has an a in front of it. That has a 2a. So if I divide by the number that's in front of this by 2, I get this number, and then I square it. So another way I could think about this is x, divide this number by 2, so this is b over x. My c is b over 2 squared. So the first things that we're going to want to do is I'm going to give you a quadratic that's in the form of x plus bx. And I'm going to see, and then we're going to come up with what the c term would be in order to make it a perfect square. So I'm going to pause the video. I'm going to write some examples of these on the board. Okay, these first examples that we're going to do are just to get in the habit of finding out what that c term is. And then once we're able to figure out what that c term is, we can work on the process of actually completing the square. So the first thing we're going to do is we're going to practice finding the c term in these, that we're going to turn these into perfect squares. So to find the c term, we're going to take half of the b term and then square it. Half of the b term and then square it. C is equal to half of the b term squared. Okay? And that turns it into a perfect square. Okay? And then we're going to write it as factored form. So what does c equal here? C is half of the b term squared. 6 over 2 is 3. 3 squared is 9. So the perfect square that they wanted us to find is x squared plus 6x plus 9. And we factor it. Notice that that's a perfect square. It's that perfect square of 3, which is b over 2. So I have square root of the first, square root of the last, which is my b over 2. Copy the sign, all squared. Okay? Next example, x squared minus 3x plus c. C is equal to b over 2 squared, which is negative 3 over 2 squared, which is negative 3 squared is 9, 2 squared is 4. Answer is x squared minus 3x plus 9/4. This last term will always be positive because a negative squared is positive and a positive squared is positive. Factor it. I'm going to put that negative 3 halves in. Quantity squared. C is half of b, which is 1.2. Okay, so my answer, and then I need to square that. Or it's actually, take that and then square it. 12 squared is 144, and then move the decimal point 2 is 1.44. So I have x squared plus 2.4x plus 1.44. Factor it. I get x, that number, quantity squared. Last example for this first type of problem is x squared minus half x plus c. So c is equal to negative 1/2 over 2 squared. So that would be negative 1/4 squared, which is positive 1/16. Okay? Now I'm going to write x squared minus 1/2 x plus 1/16. And then in factor form, it would be x minus 1/4 squared. So this first group of problems was for you to find the c term. Now we're going to expand that. Once I'm able to find the c term, how I can turn something that's in ax squared plus bx, where I already have a c, how I can kind of turn that into something that's going to be able to be solved. So the next group of examples I'm going to do is solving these by completing the square if a is 1. Okay, so if a is 1, I'm going to show you the steps. Okay, and the steps for everything else are going to build on these steps. So the first example is x squared plus 2x plus 3 equals 0. So the first thing I want to do is I want to get the number portion, that constant term, over to the other side of the equation. So I just have x's on one side, numbers on the other. So I'm going to add 3 to both sides. That leaves me with x squared plus 2x equals 3. When I do this, I leave myself a blank here. And now we're going to do the last examples. We're going to find that c term that needs to go in to fill that blank. And if I put that something in to fill that blank on the left-hand side of the equation, I'm going to put the same number on the right-hand side. So I'm going to put plus something here, and I'm going to put plus the same thing over here. Okay, and this takes us back to the last set of examples where I need to take half of that number and square it. Well, 2 over 2 is 1. 1 squared is 1. If I add 1 here, I'm going to add 1 there. The next thing we're going to do is we're going to factor this left-hand side. Well, we just made this a perfect square, which is our last examples. We take x, that number, quantity squared. Then on the right-hand side, I now have 4. And now I'm set up so I can solve by taking square roots. And this is what we did in section 9.4. I'm going to take the square roots of both sides. Square roots of 4 are plus or minus 2. Subtract 1, and I get x equals negative 1 plus or minus 2. And if these are both integers, I want the two integers. Negative 1 plus 2 is 1, and negative 1 minus 2 is negative 3. Note, you could have came up with the exact same answers by factoring this first. Okay? There will be questions on your next test that I'm going to require you to complete the square on. Make sure to read the directions where it says, if it just says solve the quadratic, you can use any method you want to. Okay? If it says solve by completing the square, you need to actually complete the square and then solve it by taking square roots. So make sure to read directions. Step 1, move everything over except for the x squared and x term. I have x squared minus 6x minus 72 equals 0. That becomes x squared minus 6x. Leave a blank. And that's going to add 72. And I'm going to also have a blank. Next thing is to find out my c that goes here. C is equal to half of b squared. That would be negative 3 quantity squared, which is 9. So 9 fills out both of those sets of parentheses. Now I'm going to factor it. I'm going to take the x, the term I have here, all squared. 72 plus 9 is 81. Take the square roots of both sides. That would be plus or minus 9. Add 3 to both sides. X equals 3 plus or minus 9. 3 plus 9 is 12. 3 minus 9 is negative 6. Final example with a being 1 is to move the 7 to the other side. So I have x squared minus 8x plus a blank equals 7 plus a blank. Figure out what goes into the blank. So I have negative 8 over 2 squared, which is negative 4 squared, which is 16. Put 16 in both blanks. Factor the left-hand side. It's x, whatever I was squaring here, all squared. 7 plus 16 is 23. Take the square roots, and I get x minus 4 equals plus or minus the square root of 23. And then the last step is to add 4 to both sides. So I get x equals 4 plus or minus the square root of 23. And this, I would want you to leave that answer. Now, one thing I want to point out, when I did the overview of Chapter 9, we said that if I had an equation that's y equals a, x minus h squared plus k, that was called vertex form. Notice that this is very, very close to the vertex form once I'm at this step here. X plus 1 squared equals 4, x minus 3 squared equals 81, x minus 4 squared equals 23. Once I have it right here, I can turn it into vertex form by moving that number back over. For example, the vertex form of this equation is going to be x minus 1 quantity squared minus 4. That's the vertex form. Same thing here. Y equals x minus 3 quantity squared, subtract the 81. And the last one would be x minus 4 quantity squared minus 23. So I can pretend like I'm solving the equation, then I can put it back into vertex form. So two things we have not done so far is we have not done it with coefficients of a's, and we have not done it when it starts out y equals to come up with just the general equation. So next set of examples I'm going to do is if I have an a term in front of it. Okay, again, we're going to solve these by completing the square, but these have a's in front of them. So again, the first step is to move that number that I have that doesn't have an x or an x squared to the other side. Then I'm going to divide everything by the number that's the a. That's the term in front of the x squared. Then I'm going to complete the square. Okay? Start out with 2x squared minus 8x minus 14 is 0. Add the 14 to both sides. So I have 2x squared minus 8x equals 14. Second step, divide by the number in front of the x squared. So I'm going to divide by 2. That leaves me with x squared minus 4x equals 7. So my next thing I'm going to do is I'm going to solve by completing the square. I need to, let me rewrite this with the blank that I did in the last examples. I need to find the c term. C is equal to b over 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Put a 4 here. Put a 4 here. Write it in factored form. That gives me x minus 2 squared equals 7 plus 4 is 11. Take the square roots. That leaves me with x minus 2 is plus or minus the square root of 11. And add the 2 to both sides. X equals 2 plus or minus the square root of 11. I have 4x squared plus 4x minus 7 equals 0. Add the 7 to both sides. That's 4x squared plus 4x plus blank equals 7 plus blank. Divide everything by 4. So I have x squared plus x plus blank equals 7/4 plus my blank. Find out what my c is. C is equal to b over 2 squared, which is 1/4. So I put a 1/4 up here and a 1/4 right here. Factor the left-hand side. I have x and then the number in parentheses here, which is 1/2, quantity squared. Right-hand side, 7/4 plus 1/4 is 8/4. 8/4 is 2. Take the square roots of both sides. I have x plus 1/2 is plus or minus the square root of 2. Then subtract 1/2 from both sides. X equals negative 1/2 plus or minus the square root of 2. Final example for solving. Okay, and then the next video we will actually go completing the square to find the vertex form. Is 3x squared minus 36x minus 11 is 0. Move the 11 to the other side. So I have 3x squared minus 36x equals 11. Divide everything by 3. Leaves me with x squared minus 12x plus blank equals 11/3 plus blank. Find out my c term that's going to go into both of these blanks. C is equal to b over 2 squared. Negative 12 over 2 is negative 6 squared, which is 36. That goes into both blanks. Factor the left-hand side, and I get x minus 6 squared. This right here, I need to turn this into thirds. Okay? So that would be 90 plus 18 is 108 thirds. 108 plus 11 is 119 thirds. And that is not divisible by 3. I know it's not divisible by 3 because if I go 9 plus 1 is 10, 10 plus 1 is 11, 11 is not divisible by 3. So that is as simplified as I can get that. So I have 119 thirds. Next thing to do is take the square roots of both sides. I get x minus 6 equals the square root of 119 thirds, which is the square root of 119 over the square root of 3. We are not allowed to have square roots in the denominators, okay? For right now, I would take that as a full answer. By the end of the semester, to get rid of the square root in the denominator, you multiply top and bottom by the square root of 3. In the denominator, I have square root of 3 times the square root of 3, which is just 3. Then in the numerator, I have 3 times 119 underneath the square root symbol. That would be 120 times 3 is 360. Subtract the 3 would be 357. And I will tell you that if you were to use the shortcuts that we did before, that there is no even root of that. Okay, there is nothing I can pull out of that. Okay, so my next step is to add, I forgot plus or minuses. For right now, that's going to be the full credit step here. Then add 6 to both sides. X equals 6 plus or minus the square root of 119 thirds. If possible, you want to simplify that first. Okay, so that's how you complete the square to solve equations. The examples that you are going to do tonight are on page 606. Guided Practices 4, 5, and 6. So those are the 3 practice problems that you're going to do after watching this video. The next video is going to be completing the square to turn an equation into a vertex form.